Welcome to CNC Learn and Build. This is Randy Johnson. Today we're going to take a look at the basics of CNC pen turning, and I'm using a mini 4th axis from NextWave CNC, which I'm running on my Shark HD 510. I like this little mini 4th axis because it comes equipped with the number 2 Morris in the headstock, so I'm able to use a number 2 Morris pen mandrel, which is readily available from various suppliers. But the first thing I need to do is to set up the pen barrel model within VCarve. Now this pen barrel model can be adapted for almost any pen blank out there, just by changing some of the dimensions. The first thing you need is to get your pen kit, your bushings, and your pen plank together, because the pen barrel tube and the pen blank and bushings, there's some dimensions here you'll need for setting up your VCarve setup. Within the job setup window, of course, we're going to be using rotary today. And the length of the job size, you'll match that to the length of the pen barrel. In this case, that's 2.21. The diameter of the job set, I typically set that up slightly smaller than the dimensions of my pen blank. So in this case, it's 0.7, where my pen blank is 0.75. It also gives me plenty of material after it's rounded, because most pens are a 1/2 inch or less or thereabouts. For the 0Z position, I like to put that at the center of the axis because that's very repeatable and very consistent. And then also I use an XY datum in the center location as well. For the mini 4th axis on my HD5, I like to set it up in the X-axis for pen making. It just allows me to watch the action better, and it's a simple setup. However, depending on your machine, you can also set that up in the Y-axis. If you do have that checkbox called Flip Design Check, it actually allows you to toggle between the X and the Y axis and automatically flips your design. So again, depending on your setup, that's one other option available to you. Within the VCarve window, I've already entered some information here. You've seen here where I have drawn a cross-section or a profile of the pen barrel as well as the bushings. I'll pull the dimensions for the bushings right off the instructions that come with the pen. We'll take a look at those closer later. But the pen bushing in this case is 0.47. I've also drawn a 1/2 profile of the pen barrel and drawn in a little arc here of 0.02. And then the 0.37 over here at the right side represents 1/2 the dimension of the bushing, or 1/2 the diameter of the bushing. First thing I need to do is to bring in an existing model or create the model for this. Now here's a little tip and trick. I'm actually able to use the 3D tab right out of the clip art window and use that as a starting point. So this circular 3D tab, the 3/4 inch one, I double click on that, and that inserts it into my job setup area, my drawing area. I need to rotate it, and I'm going to click the 9 key a couple of times to rotate that up in the vertical position. And now I want to take and split my windows so I can see what's going on in both the 3D and 2D window. And you can do that in the upper right corner. I'm also going to switch from the wrapped or round view in my 3D window to the flat view. So the red model that you see there in the lower right, that's actually this 3D model in the flat view. Next up, I want to start sizing this 3D model to fit my job setup area. So I'm going to open up my set size window, set the anchor point to the middle, and then for the width in the model or the job size, I'm going to use the 2.21, which is the length of the barrel, enter that into the width, and then click apply. You'll notice in the 2D window and the 3D window how that model has now stretched out to the width of my job setup. I want to stretch the model to the top and bottom of the job setup. First, I want to make sure that my snaps are active in the top of my work area. And then I'm going to grab that handle in the middle of the top of the 3D model there in the 2D window and stretch it up till it snaps to the top of the area, and then stretch it down till it snaps to the bottom. And you can see in the 3D window on the right there how the 3D model is now full size, covering our entire job setup window. Next up, I'm going to switch over to the modeling window because I need to make some adjustments to this model. And You'll sometimes have the zero plane automatically active. So if it's automatically active or visible, just turn it off. We won't need the zero plane for this setup. But then select the model. Number 3 right there, go ahead and select the circular tab so that's active, and then select the wrench at the top to open up the component window. This is where we're going to set the arc height by entering that into the shape height. When you enter that in, you'll notice on the right side how the 3D model is now very shallow or very low profile with a very slight arc to it. And that's the arc of our curve. But we still need to add some base height to this. And for that, we'll use the radius of the bushing or half the diameter of it. But I like to add a little extra to this. A couple of reasons. It gives me makes the pen barrel a little oversized for sanding. It also keeps the router bit from touching the pen bushings during machining. So I just add a little extra in and enter that into the base height. And you'll notice on the right side now how we have a slight arc at the top of this 3D model, and then we have the base height or foundation to it below it. And that'll give us our 3D model for this pen. Close out of that window. I'm going to switch back to the wrapped or this round view of the 3D window and open up my toolpath window because we're now ready to set up our toolpaths. For this basic pen model, we'll need 3 toolpaths. We'll need a rounding toolpath to take the square stock down to round, and then we'll need a 3D roughing and a 3D finishing toolpath. The 3D roughing toolpath will rough it down, leaving us a little bit of material to take off with the 3D finishing toolpath. So in VCarve Pro or Aspire, you could use the gadget window and use the create rounding toolpath. Now, if you have VCarve Desktop, gadgets are not available to you. So if you check in the description below this video, I've included a link there to another resource for how to create a rounding toolpath within VCarve Desktop. It's a little bit of a workaround. It's not quite as easy as using this gadget, but it gets the job done, and then everything else about what I'm showing here you can still do in VCarve Desktop except for this one step. So check that out if you got VCarve Desktop. If you want to upgrade to VCarve, this is obviously one good reason to do that, but it's not an absolute requirement. You can still create your pens within VCarve Desktop. You just have to go about the rounding toolpath a little differently. But if you have VCarve Pro or Aspire, go ahead and click on Create Rounding Toolpath Gadget, which will open up the gadget window. Of course, we're using square stock, so we need to go ahead and select that option at the top and then enter the dimensions for that square stock. Next, we're going to go ahead and use the optimized raster because we want to knock the corners off of our square stock. For this setup, we also do not need to enter any allowance because we're going to be taking this round cylinder down even further for our 3D model for our actual pen barrel. So leaving that at 0 works just fine. However, we do need to select a tool for this setup. So click on Select. That'll open up your tool database. Now I like to use a 1/4 inch ball nose for all 3 tool paths. That way I can save them together and run them together. For this rounding tool path that we're setting up now, I'm going to go ahead and change out the pass depth to 0.025, a fairly shallow pass depth. Set the step over to 30%. I'm using a spindle, so I'm going to set that to 20 thousandths and a feed rate and plunge rate of 120. If you have a different setup, you may need to adjust these up or down to fit your particular setup. I then click on Apply down the bottom and select to bring it into my gadget window. This ball nose bit is now listed there in the gadget window, as well as the name that it's going to give this tool path. You can change this, but I usually just leave it as rounding tool path because I know what that means. If you check at the bottom, you'll notice how the cylinder length and the diameter, this information comes right over from your job setup. So the length, of course, is the same as your barrel, the tube for the pen, and then the 0.7, of course, is the diameter of our job setup. So this rounding tool path is going to take the square stock down to this 0.7 inch diameter. And from there, we'll then machine it down further for our final pen. We click OK to exit this. We now see the toolpath listed on the right side, and you can see the blue lines in the middle here show us how this toolpath is going to knock the corners off of our square stock. Step, we want to select the 3D roughing toolpath, open up that window, and we're going to select the same ball nose bit that we used in the previous toolpath. You don't have to make any changes, just to select it and bring that into the roughing machine toolpath here at the top. And next, for the machine boundary limits, we're going to set it to the model boundary. We are going to add a little allowance here because we want to leave a little bit of material for the 3D finishing toolpath to take off. I'm going to set it up at a raster, and that way it'll go along the length of the barrel, which would be a very efficient setup. And then I'm going to click Calculate to calculate this toolpath. Now see how this toolpath looks a little different than the previous one. And we can preview it, and that's what the stock will look like after it has run the 3D roughing toolpath. The grooves that you see there are because of the 30% step over. These will then be removed once we run the 3D finishing toolpath, which is the next one that you want to select from your toolpath window. Again, you're going to select the same 1/4 inch ball nose bit and insert that in at the top. However, next you want to click on the edit window, that little edit button on the right side. This will allow you to edit the setup just for this occurrence of this 1/4 inch bit. The only change you need to make is changing the step over to 7%. We want a nice tight step over so we get a nice close, nice smooth finish on the pen barrel when it finishes off. Click OK, and then go ahead and use the same settings for the model boundary and the raster that we used on the roughing, and click Calculate. We now see that the blue lines representing the toolpath lines are very close together because it's going to give a nice tight toolpathing to give us a nice smooth finish. And of course we can preview that, and this is what a simulation of what the final barrel will look like with a slight arc to it. We close out of that, and we're actually ready to save our toolpath. So click on the save icon. That will open up the save window. Since we're going to save all 3 of these together, you could use the middle option at the top and then check all the boxes by all 3 toolpaths. That way they will all be saved out into one TAP file or one G-code file, which you then can save out to your thumb drive and take to your pendant to run the toolpaths. From here, we now need to turn our attention towards prepping the material. And for that, I recommend, as I mentioned earlier, there are instructions available for all the different pens. These are readily available for download online from the various pen distributors and retail stores where you buy your pen kits. They're very nice because they give you all the really important information about the diameter of the drill bit, the diameter of the blank, the diameter of the bushings that are required, as well as some assembly instructions. So there's lots of helpful information on this. So go ahead and download that, read through that as you prep your material. But the first step in prepping the material is you're going to cut your pen blank material to length, and it's typically cut it a little longer than the brass tube that you're going to use for your pen kit. And I often will just round it up to some even dimension. It's not real critical. You just want it to be a little bit longer. The next step is you need to bore out the center of that pen blank with a drill. Now the drill bit diameter will be specific to your pen kit, and that'll be specified in the pen instruction worksheet as well. And depending on what setup you have, if you don't have a good way to hold your pen blank vertical, I find that this centering drilling jig works really well, and I just have it set up with this little drill press just dedicated to this purpose. You test fit the tube just to make sure there's no places where it's going to hang up inside, and then you want to prep the tube by sanding it to get any tarnish or oxidation off the surface in preparation for gluing. CA glue is a very common glue to use when you're gluing your tube into a wood block. Epoxy is another option, and you want to leave a little space on both ends just to make sure that that tube is centered inside that blank. After the glue has dried, you want to flush trim the end of your wooden block, your pen blank, flush with that brass tube. There's a couple ways that it can be done. These accessories are available from pen distributors, the reamer and the centering shaft that goes down inside the barrel, and then the counterbore attachment. That counterbore attachment, you just want to run that down until it just touches the brass. And the centering shaft or the reamer at the middle has a couple functions. One, it holds the counterbore square with the end of the brass tube, And then the reamer also removes any glue from inside the tube if there's a drip of glue inside there. So they're a nice setup. And again, these will come in different sizes depending on your pen kit. Another option is you can also take your pen blank and take it to a disc sander with a miter gauge and sand it up as well. If you don't have any concerns about there being glue inside, then that approach works really well also. Now ready to go ahead and insert your bushings inside the barrel. This setup, as you see here, is what's going to be mounted onto the mandrel. And I mentioned earlier how I use a number 2 Morris taper mandrel. This setup works really well on the mini 4th axis because it just fits right into the headstock, and I could use some spare bushings and a plastic tube for spacers, and then a couple of knurled nuts on the end. Now most mandrels come only with a single knurled nut, but I have found that because the CNC rotates back and forth, that single knurled nut tends to come loose. So I put a second knurled nut from another mandrel that I have, and it acts as a lock nut. And I tighten it down really tight because you want that to be really snug on there, because the end pressure is the only thing that's keeping that block of wood from rotating on the mandrel shaft. And so that's why that heavy compression from the ends will keep that nice and tight. And then mount that into the headstock of your rotary tool. In this case, I have also extended the center point on my tailstock quite a ways. And the reason I've done that is so that when I'm done turning, I can slide that center point back into my tailstock, and I can pull out my pen mandrel with the Morris taper and it clears the tailstock. So I don't have to move my tailstock out of position. So it allows me to get into a routine of loading up pen blanks, sliding them in, turning them, pulling them out, putting on a new one, and I get into a little production situation while I'm turning it, and all the setup of my mini 4th axis headstock and my tailstock just remain stationary. Of course, just like with any CNC setup, you need to zero out the Z. And since the Z is set to the center of the material, you obviously can't reach the center of the material with the tip of your bit. So what I like to do is I put the bit down to the top of the center point on the tailstock, and since the center shaft there is a 1/2 inch diameter, I know that the top of that is a 1/4 inch above my Z0. So then I manually set my pendant to 0.25 for the Z, and that's the same as zeroing the Z out to the center of my pen blank. Now, if you're unfamiliar with how to manually set up your pendant for manually setting the Z, I've included a link in the description below for some information where you could go to find information about using your pendant. And now this is specific to a CNC Shark tool, but other pendants and other machines work in a similar fashion. But the point is, you need to set up your Z so it's centered up to the middle of the material. Now, sometimes I get asked, why not just center it to the top of the material? Well, if you stop to think about that square, first of all, that 3/4 inch pen blank, it's unlikely, it's rare that they're exactly 3/4 inch square. They might be a little more in one dimension. Also, your hole going through the middle might be a little off center. So it's just simply not accurate going off the top of the material. So I prefer to do it this way. Plus, once I have my Z set up, I could use that and I could run pen blank after pen blank after pen blank, and I never have to reset my Z. After I've done that, then I switch and I go ahead and zero out the X to the middle of the material. That is, the pencil mark you see there in the middle for the X. Now my Y0 is centered out to the middle of my shaft between the headstock and the tailstock. And that's something I set up when I assemble my mini 4th axis on top of my table. And so with this setup, these 3 0 points of the Y, the X, and the Z, when I change out to a different pen design, the only one I have to reset is the X0, because my pen blank is a little different. If I'm making a whole bunch of the same pens, I don't even have to re-zero that one. But the Y and the Z, as long as when you're running a set of pens, those don't change. Just the X0 if you have a new design. So it becomes very convenient to run a series of pens on the mini 4th axis with this type of setup. So we're ready to run the toolpath. And of course, we're going to run them all together. So the first one that's going to automatically run will be the rounding toolpath. And that's going to take the square stock down to a round cylinder. That's where it gets its name, rounding toolpath. And so we have here now is a 0.7 inch diameter round cylinder. And from the next one that'll run after that will be the 3D roughing that we saw earlier. And that starts to give our pen some shape, takes it down in diameter. Still a rough finish because it's just the rough surface or the rough toolpath. And we'll finish it off with the 3D finishing toolpath to the final diameter. Now you can see there it's slightly oversized over the bushing. I do that intentionally for a couple of reasons. It's going to be a little sanding space when I get it to the sanding stage, but I try to avoid having the router bit hit the bushings, and that's why I give myself a little bit of clearance. Another tip here is that once you get used to this setup, you can actually run undersized bushings. You don't need to run the actual size bushing. And when you run an undersized bushing, then you have lots of clearance to prevent the bit from touching the bushing. So there's a couple options to work with. When you run a few pens, you realize how you can get by. Unlike wood turning lathes, the bushings really only play the role of holding this pen part in place. On a woodworking lathe, they're actually used to size it at the ends, but you're not relying on it in this case because the router bit is programmed to do the curve. Again, if you're unfamiliar with pen turning, this will sound new to you, but if you've done some pen turning, I think you'll understand what I'm talking about. And once you run a couple of pens, it actually becomes pretty routine to get this pen blank size right down to the right size for your pen kit. At this point, we're ready to go ahead and sand the pen blank. Now, most CNC rotaries don't have a high-speed operation. They don't rotate very fast. So unlike a woodworking lathe, you can't ramp them up to do the hand sanding. They just simply don't go fast enough to give a good sanding. So what I usually do is I'll take and unmount it and put it onto another pen mandrel, and I chuck it up in my drill, and I just have a little sanding station set up for this, where I've got a pen mandrel in my drill, put the blank on it, and then I use various grits of sandpaper. Often, I usually find I'm running between 220 and 600 for most of my setups, but depending on the material and the finish that I want, I may drop down to 120 and all the way up to 1,000 or more, depending on the particular material. But this works pretty well as opposed to trying to do it on the CNC rotary. Of course, it's a good idea to clean off any dirt or dust off that prior to finishing it. And in this case, I'm using a rub-on lacquer finish, which I like because it's easy to use, it's quick, I can put multiple coats on, I can get different levels of sheen from really a satin finish all the way up to a gloss finish using the lacquer finish. Another really popular finish is using straight up CA glue. It's a little trickier to use, but it gives you a very glass-like finish, and it's absolutely beautiful. So that's another option. Lots of finish options out there. These are just a couple of them. Of course, you're going to use your pen press then to put the pen together, and you've got your pen. Now, this pen barrel that I have shown you here is your basic pen barrel, just a simple, smooth pen barrel, the same thing you'd get off a woodworking lathe. Takes about 15 minutes to turn it on the CNC. You could probably do it quicker on your woodworking lathe. However, once you have this basic pen barrel, you can then, like I said, change the specs of it for different types of pen kits. But you can also embellish it very easily using VCarve or Aspire. You could very easily add flutes to it if you'd like to do that with a simple straight line fluting in the bit. You could do cross hatching. You could do VCarve engraving. All available within VCarve or Aspire, including VCarve Desktop. You could do all these embellishments. Now, if you want to find out more information about how to do some of these embellishments, I've included some additional links in the description below. Check that out also if you want to learn more about adding details to your pens. One other option you have is that if you do switch to plastics, there's a wide variety of plastics, very interesting colors and combinations of plastics. They machine very nicely on the CNC, and then you sand those up and buff those up with plastic polishes to create pens similar to these. Now, if you do have Aspire, Aspire opens up even another world of availability for pens. This octagonal shaped pen, which you notice actually transitions to round at both ends. I created this inside Aspire, and this is something you can't do in VCarve nor can you do this on a standard woodworking lathe very easily or at all. But with an Aspire and on a CNC, this is a very easy process once you get it programmed in and create the file. So you can create some very unique pen shapes when you combine Aspire with your rotary attachment on your CNC machine. Hope you found this helpful. I'm Randy Johnson. Thank you for joining us at CNC Learn and Build.